Hello, I'm Jerry Laws, the editor of Occupational Health and Safety magazine. Welcome to this one-hour live presentation, which is titled Get the Facts, the Truth Behind the Real Cost of Burns. It is sponsored by DuPont Nomex. Today's speaker is Caroline Holtzman, DuPont Nomex FR Technical Leader and a member of the DuPont Protection Solutions North America Thermal Apparel team. She has a bachelor's degree in chemical engineering and a master's in systems engineering, both from Virginia Tech, and 12 years experience in the industrial fiber and fabric industry. Today she'll discuss the direct and also the hidden costs of burns and the benefits of an appropriate burn PPE program. You can submit a question for our presenter at any time during the presentation, and I will moderate a Q&A session during the final minutes of the hour. If you experience technical difficulties, click on the Help button located below the slide window and you will receive technical assistance. Finally, after the session is complete, we will be emailing you a link to the archived version of this webinar so you can view it again or share it with your colleagues. And now I'll turn it over to Caroline Holtzman.
Thank you, Jerry, and Occupational Health and Safety for this opportunity to participate in a webinar. Thanks also to those of you today for your time as you listen and we consider how costly workplace burn injuries really are. I'd like to start with an overview of workplace burn injuries, what they are, why they exist, and their associated cost. We will talk through hazard assessment, selecting personal protective equipment or PPE solutions targeted to burns, and then wrap up with some conclusions and summary information. Let's get started. Workplace burns come from multiple sources like flame or fire, chemicals, or burns resulting from an electrical event like an arc flash. These are the types I will be focusing on today. These are different threats that should be considered in any company's hazard or risk assessment. In a workplace environment, one type of burn hazard may exist by itself, or different types of burn threats could be identified together in a single job function and may require different solutions to eliminate or control. Let me give you an example of what I'm talking about with a multi-hazard work environment. In a few minutes, I will reference an example of unloading raw materials at a manufacturing site. Based on the material being unloaded and the environment where the unloading takes place, it is possible there could be a double burn threat, one from fire or flame and a second chemical burn. Arc flash is almost always a dual threat. An arc flash produces so much heat that it typically presents a fire hazard as well. Safety managers and industrial hygienists have competing needs for risk reduction and a limited budget to address these needs. The first question you may be asking yourself is, just how big is the problem of workplace burns? Burns are only a small percent of workplace injuries at 5%. They account for only 1% of all injuries in the United States. But compare burns to all other non-burn injuries combined. The average hospital inpatient stay is almost twice as long. The average cost of that hospital visit is more than twice as much for a burn versus other injuries. The Centers for Disease Control and Prevention report estimated medical costs for burn injuries in 2010 totaled $1.5 billion, with another $5 billion associated with lost work. Those of us in the safety industry are sensitized to falls on the job, which makes sense. Falls are the #1 source of workplace accidents. OSHA statistics show there were over 309,000 on-the-job falls in 2015, compared with only about 23,000 workplace burns. But if you consider the resulting medical cost, a burn injury is on average 5 times more costly than a fall. What are the main causes of workplace burns? The first is a failure to recognize that a burn hazard even exists. They are easy to overlook in a hazard assessment. Other causes are employee inexperience, situations where safety regulations, procedures, and equipment are in place but not in practice, a lack of training, and employees who are just not using required PPE or following safety procedures. Later on, I will be suggesting a tool that could be used to improve that last cause, worker noncompliance, for burn protection PPE. Burns occur most often in manufacturing facilities, accounting for 29% of all workplace burns. This is twice as high as the next category. The other industries or locations, in order from largest to smallest, are electric appliance companies, restaurants, particularly fast food and pizzerias, construction companies, on-the-job car accidents, chemical plants, and paper mills. For workers burned on the job, it's interesting to note that just over half are unable to return to the same company to perform in the same job function without some sort of accommodations. Skin is our largest organ, forming a protective barrier to the environment and regulating human body temperature. Skin burns are divided into three main classifications: first, second, and third degree burns. Two factors determine the degree of burn: the temperature the skin is exposed to and how long that exposure lasts. Human skin begins to burn at 109 degrees Fahrenheit. First degree burns are superficial, affecting only the top surface of the skin. Second degree burns go deeper, and third degree burns are referred to as full thickness burns because they go through the full thickness of skin. Second degree burns are the most common degree treated in the ER and make up the majority of hospital inpatient stays due to burn injury. Let's look at workplace burns and how they relate to OSHA standards for workplace injuries. First degree burns are relatively minor injuries that can usually be treated with over-the-counter medication and typically are not considered OSHA recordable. Without complications, they take 7 to 10 days to heal. Second degree burns generally take at least 3 weeks to heal, and the most important part of treatment is to protect against infection. OSHA reporting regulations are not specific to the degree of burn. They don't call out first, second, or third degree. Instead, any burn injury that requires hospitalization, prescription medicine, or results in restricted work, a job transfer, or days away from work, that is OSHA recordable. Third degree burns are always a recordable injury and have significant and permanent impact to the victim. Electrical burns involve intense levels of heat, and they are almost always third degree burns. We just talked about burns measured by skin depth as first, second, or third degree burns. The span or coverage of a skin burn is measured in a different way. Coverage of the body injury is calculated with a method called TBSA, which stands for Total Body Surface Area. Doctors are able to estimate what % of a person's skin surface is burned using a system called the Rule of Nines. First, the body is divided into sections based on 9%, or a fraction or a multiple of 9%. The head represents approximately 9% of our skin. Each total arm, front and back, just the front of each leg, and just the back of each leg represent another 9% each. The chest and the back are each twice that surface area, so that makes up the final two parts at 18% each. Legs are the part of the body most frequently burned. If we wanted to calculate the TBSA for a patient with both legs burned on both front and back, this would be 4 areas times 9%, or 36% TBSA total body surface area. The American Burn Association, also known as the ABA, is a world-recognized leader in burn injuries. One of the things they do is provide burn treatment protocols to the medical community, including hospitals and burn centers. The ABA recommends that any patient with the following injuries should be treated in a specialized burn center. Patients with more than 10% TBSA total body surface area, anyone with third-degree burns or burns in particular areas of the body, patients with inhalation or lung injury accompanying their burn, and those with other pre-existing health problems. The last bullet is a special note for workplace burns. Any victim of a chemical or electrical burn is recommended for treatment in a specialized burn center. More than half of all U.S. burn patients are treated in a burn center. We have approximately 123 burn centers in the U.S., and most of these are subspecialized to treat only adults or only children. This graph shows that the number of fatalities from burns has steadily fallen since 2000. The reason is improved medical treatment in the specialized burn centers I was just mentioning, as well as improved safety and PPE. All of this is good news, but the number of burn deaths is still significant. In 2015, the most recent available data, 3,146 people died in the U.S. as a result of a burn injury. The chance of survival depends primarily on the percent of total body surface area burned. Each orange column of this graph represents a range of 10% body burn, starting from 0 to 10% on the left, up to 90 to 100% on the right. Today, survival is nearly 100% for burns less than 10% of a body surface. As the burn coverage increases, the chance of survival decreases. Before the introduction of specialized burn centers in the 1970s, the chance of surviving even a 20% body burn was about 0. In 1998, survival rates had improved, but the chance of surviving a 90% or greater burn injury was essentially 0. Today, we have moved that mark up to 12% survival rate for 90+% burn injuries. Another important factor that contributes to the outcome of a burn injury is the age of the victim. This data shows the survival rate by the victim's age grouped by 10 years. 25% TBSA burn injury is shown in the black columns, with 50% burn area in orange and more severe 75% TBSA in gray. In all age ranges, as the coverage of burn injury increases, survival rate decreases. Said another way, the black bars are higher than the orange, which are higher than the gray. There's very little difference for the 20 to 40-year-old age group and the 30 to 39-year-old age group. But starting with burn victims age 40 years and up, there is a change, a downward trend in survivability. Older burn victims over the age of 40 are much less likely to survive both the less severe injuries, shown in black, as well as the more severe injuries in orange and gray, as compared with younger patients. Burn injuries are devastating, with long-term treatment needs and lifelong effects. Burn victims can suffer from chronic pain, permanent scarring, lifelong itching, sleep disorders and chronic fatigue, depression, and PTSD. Employees with burn injuries may require modified clothing, equipment, and even special working conditions, such as temperature and humidity-controlled work environments. Another thing the American Burn Association does is collect data from 96 major U.S. hospitals and burn treatment centers to create a report called the National Burn Repository. In this report, they averaged the last 10 years of data to provide all sorts of statistical results. This graph shows the average hospital stay for a burn patient based on the degree of burn injury. As the percent TBSA increases from left to right, the average time of hospital stay also increases. The data is broken down between survivors and non-survivors. Survivors are shown on the black line. Non-survivor data is shown on the orange line. The average for all burn patients is shown on the gray line. The average hospital stay is highest for survivors and peaks at 86 days for an 80 to 90% body burn. For a burn patient that dies, the maximum time in the hospital is 20 days, almost consistently for the range from 10% to 70% TBSA. It is great news that more people now survive more severe injuries, but the trade-off is longer, more extensive, and more expensive hospital stays. I would like to point out the last black data point on the right for a survivor with a 90 to 100% body burn. It looks at a place where it trends downward. Recall that only 12% of burn victims will survive a 90+% burn injury. So there are fewer patients in this subset, and the survivors in this category are almost always younger, so they recover faster than the average patient. For the non-survivor data in orange, the more severe the burn injury, the fewer days of survival, so the time in the hospital at 60% or more burn injury starts to trend down. As a companion to the last slide, let's look this time at hospital cost versus percent body burn. Using the same color schemes as before, patients who lived are shown in black, patients who died are shown in orange, and the average of both is shown in gray. There are more survivors at the lower burn injury level and a higher percentage of deaths at the higher burn injuries. This explains why the gray average hospital cost is more directly aligned with survivor cost in the lower left of the graph, and then closer to the non-survivor orange data on the right. Costs trend up for survivors to the 70 to 80% total body surface area. The associated hospital charge for this level of burn is approximately $1.2 million per patient. Recall that time of hospitalization is flat for most non-survivors at about 20 days. Thus, associated hospitalization costs for non-survivors are also relatively flat at about $400,000 per patient. Costs to treat a burn victim are very high. You may be wondering why. Let's take an example, a patient with a burn injury of 30% TBSA. This person would be expected to spend an average of 23 days in a hospital or burn center, including 15 days in the intensive care unit, and will require, on average, 4 surgeries related to the burn injury. Many victims of severe burns are better initially treated in a medically induced coma, thus the ICU days. The average medical cost for this patient with a 30% TBSA would be expected to be around $400,000. Medical costs are sometimes just the tip of the iceberg for a burn accident. Companies that experience an on-the-job burn injury could expect to see incremental costs for administration time dealing with the accident aftermath, OSHA fines, litigation, legal, or settlement expenses, increased insurance premiums, a modified work schedule or environment for the affected employee, which could be either short-term or long-term, overtime, new training, cross-training, downtime, and a drop in productivity while the affected worker is out, and damage to the company's public image or brands, which also goes directly to the bottom line. Let's look at some of these in more detail using actual real-world examples. The next few slides chronicle companies that have experienced a serious on-the-job burn incident. The first is an accident where a chemical spill resulted in a fire. In 2008, a lab technician in a University of California research lab was at work, wearing a synthetic fiber sweatshirt, PPE goggles, and gloves. As she transferred a highly unstable liquid from one bottle to another, the liquid spilled and instantly ignited. She was not wearing the chemical supplier's recommended personal protective equipment, or PPE. This lab technician suffered third-degree burns over 40% of her body and died 19 days later in the hospital after multiple surgeries. The OSHA fine from this accident was $31,875. The university and the professor responsible for the lab were charged with 4 felonies, which could have resulted in 4.5 years in prison if convicted. The university settled with the Los Angeles district attorney, but initially the UCLA faculty member did not, and the university was responsible for his defense. At the end of the day, UCLA paid out $4.5 million in legal fees. Compare this with the cost of a commercially available, fire-resistant, and chemical splash protective lab coat at about $175. Let's look at an accident with an electrical source that resulted in an arc flash and fire. In August of 2013, an outside contractor was working at a Qualcomm facility in Los Angeles. There was a miscommunication about lockout-tagout, and the contractor removed the protective cover from a live 4,160-volt circuit breaker. He was holding a metal measuring tape in his hands at the time. An arc flash occurred, setting the victim on fire, resulting in a 35% TBSA. The victim was initially hospitalized for just over a month and underwent multiple surgeries. A jury trial resulted in a $7.1 million verdict for the victim, with fault shared between Qualcomm and the subcontractor. Compare that cost to a typical workplace fire-resistant and arc protective coverall at about $130. A company specializing in arc flash safety training reports that the total estimated cost of one arc flash workplace injury is approximately $14 million when you include legal costs, medical costs, workers' compensation, OSHA fines, property damage, production losses, and training. Remember that electrical burns are usually deep and severe. A study done in 2010 found that 39% of electrical workplace burns could have been prevented with the use of appropriate PPE gear. Let's consider one last example showing the consequences from a workplace chemical burn. Personnel at Aluminum Shapes LLC in DeClaire, New Jersey were draining a tank without proper PPE and suffered chemical burns. One of these employees required hospitalization, but OSHA was not notified. This time, the major financial hit came in the form of fines. A follow-up inspection by OSHA resulted in an initial total fine of $1.922 million from 94 separate violations that addressed deficiencies well beyond the chemical burn hazard. OSHA has inspected this facility 8 times since 2011. All of this could have been prevented with a robust hazard assessment and the resulting safety program. Medical claims from burns or other injuries increase costs by driving up workers' compensation premiums. Insurance plans for workers' compensation vary by state and the type of coverage, but there are a few common denominators that will dictate how much your premium will be, including the type of business you do, the size of the company payroll, and the seriousness and number of workplace injuries. The insurance industry uses a system called the Experience Modification Rate, or the abbreviation EMR, to determine what a company pays for coverage. Just like your car insurance, where accidents and tickets work against you for years, workplace medical claims are usually used in the EMR calculation for 3 years to determine a premium. A hit to your EMR not only will increase your premiums, it can also affect your ability to bid or perform work. Here at DuPont, only companies with a minimum EMR of 0.99 are eligible to quote or do work at any DuPont North American site. Burn or other workplace injuries have a measurable financial negative effect on the company's reputation and brands. How? through price drops and market share loss, higher operating cost, paying more for credit, poorer terms with vendors and suppliers, and higher regulatory burdens like increased inspections. Both BP and Massey Energy experienced huge drops to their stock price just after explosions and fires. A year after the oil leak in the Gulf of Mexico, BP stock was still down 26%. 2 years after the accident, the company announced it was undertaking a $500 million rebranding program to improve the company image. Massey Energy saw their stock fall 11% in one day after a catastrophic mining incident. About a year later, the company was sold, and the Massey Energy Company no longer exists. I hope you now see that workplace burn injuries, whether they come from fire, chemical, or electrical accidents, are a big deal. This brings us to the next question. How do you eliminate or reduce your risk? Step one is hazard identification of burn threats in your facility. Risk assessments are time-consuming and costly, but of the utmost importance. Remember, many burn injuries occur at sites that have an active risk assessment and safety program. They just overlook the threat. There are different ways of developing a risk assessment program for your site. Some companies prefer to conduct their own analysis using their own people and their own systems. An assessment tool can be purchased, or safety personnel can go outside for training. Companies or consultants will come to your site for a fee to perform a hazard or risk assessment. Whatever method you use, the goal is the same: to engineer out as many threats as possible, look for alternatives and substitutions, and then control remaining safety threats with an appropriate PPE program. PPE covers an enormous area. Workers need different types of PPE protection for different types of threats. Burn protection is a small little subsegment of PPE. The science and technology behind just burn protection is complicated, with different threats, different threat levels, different regulations, standards, and certifications. We've talked today about how so many work environments can include multiple burn threats, like fire with chemical or arc with flame. Matching your hazard assessment results with PPE solutions can be an overwhelming task. DuPont and other companies in the protection business offer tools and resources to make it easier to match threats with solutions. DuPont Protection Solutions Division is in the business to provide technology, materials and products, clothing and accessories to deal with safety threats from ballistics to chemicals, fire to cut protection. We developed our free online assessment tool called SafeSpec to help employees, purchasing managers, and safety personnel navigate the selection process for PPE. Let's say you've completed your hazard analysis and risk assessment and have identified a fire or a flame burn threat. The next step is to go to a website like SafeSpec and type in your assessment results. For our system, the first input is to choose your industry. Each input is designed to drive the process towards a more specific PPE solution matched for the user. These are screenshots from our SafeSpec program. The photo on the left is from the heat, flame, arc, or hot metals threats. The photo on the right is for the chemical protection SafeSpec process. The system will lead you through a self-guided set of user inputs. You choose things like the type of threat, the standards or certifications that must be met, and the garment type. Is your work environment best suited for pants and shirt, coveralls, outerwear jacket, or lab coat? Do you need gloves or protective sleeves? What color choices are available? What fabric weight do you need to match your protection level? All of this information allows SafeSpec to guide you to the proper PPE for your individual needs. The final goal is to partner the need with commercially available products. The system works for hazards, for fire and flame, arc flash, chemical protection, cut protection, or a combination of these threats. As I mentioned earlier, multi-hazard work environments are one of the most complicated ones to address with PPE. They may require a combination of multiple products or one product designed with multiple functions. Let's go back to the unloading scenario. If you are a manufacturing facility, you have raw materials coming in that need to be unloaded. If the unloading environment has a flammable and toxic threat, there is a flame resistance and chemical resistance PPE requirement to protect your own employees or the outside contractors doing the unloading. It would make sense to buy an FR garment, like an FR coverall, and then put a chemical protective garment, like a CR chemical resistant suit, over it. If there's both a chemical hazard and a fire hazard, you need both types of protection at the same time. But not all products are designed to work together. Many commercially available chemical resistant suits are flammable. If you have a fire and the chemical suit burns on the surface of the FR garment that's right underneath it, the FR garment cannot do the job it was designed to do and provide the protection it was designed to offer. This is an example of why it's vitally important that the PPE components work together. DuPont offers a special line of Tychem 2000 SFR secondary flame resistant chemical overgarments designed to work specifically over FR flame resistant garments so that everything works in the event of a chemical exposure, a fire, or both. Another example we've been talking about today is the multi-level hazard of flame resistance with arc flash protection need. There are 4 different industry standards or certifications that usually apply to an FR plus arc flash garment. This is a situation where you may need one garment to meet at least these 4 different standards, if not more. Cost and functionality can be optimized with a one-stop solution like DuPont MHP, an engineered blend of 5 fiber components optimized to give garments an ideal combination of both flame resistance and arc protection, as well as comfort and durability. For people who make PPE purchase decisions on a daily basis, there's so much to consider. Hazard assessments are the most important part of the process, so the risk for each individual job for your workforce and outside contractors is thoroughly investigated. Each hazard has its own set of testing standards, along with OSHA standards. For job functions with multiple hazards, it is important to take a systems approach to PPE, making sure each component is compatible with the others. Protection, comfort, and price are all critical to buying decisions, but PPE decisions should also consider the life cycle of the product. Sometimes the cheapest thing off the shelf is more expensive in the long run. Let's go back again to the hospital data for varying severity of burns. Buying a product that performs even slightly better could save thousands of dollars in risk aversion. Selecting a product that yields a 0 to 10% predicted body burn instead of a 10 to 20% predicted body burn could save over $80,000 in medical cost. A reduction from 25% down to 15% would save $160,000. Flame retardant standard NFPA 2112, which is the National Fire Protection Association standard on flame-resistant garments for protection of industrial personnel against flash fire, requires that FR garments protect the wearer to less than a 50% predicted body burn after exposure to a heat flux of 2 calories per square centimeter per second for 3 seconds. A product that just meets this minimum standard would equate to an average of $750,000 in medical costs in the event of a burn injury. A product that exceeds the minimum standard could easily reduce this potential medical payout by half. Protection levels may not be the same for products certified to the same standards. Let's look at the side-by-side performance of two commercially available FR coveralls that meet that FR standard NFPA 2112 that I just spoke about. Both were tested in the DuPont Thermo-Man UL certified testing laboratory under the same test conditions. The Thermo-Man mannequin records data from 122 heat sensors on the surface of the mannequin body and then uses a scientific model tied to medical burn data to predict the percent body burn a person would suffer, the same TBSA values we've been talking about. The flame or fire event is simulated with 12 propane torches that are evenly spaced around the full perimeter of the mannequin to create a fireball. The next few photos were taken during an actual test in the Thermo-Man lab. The video of this test is available online in addition to other lab tests of different garments under different conditions. I mentioned at the beginning of the webinar that one of the causes for burn injuries is an employee noncompliance with safety procedures and PPE use. Some facilities with FR requirements for protective equipment have had success using the Thermo-Man videos as an employee safety awareness tool to stress the importance of burn threats and proper PPE use. If you are interested, a link to our Thermo-Man video library is located at the bottom of this slide. Each test consists of the mannequin wearing a men's standard size coverall zipped and snapped up over cotton undergarments to simulate how a person would be dressed in the workplace. The coverall on the left is made with Nomex 3A 6-ounce fabric. The commercially available coverall on the right is 7-ounce fabric made of an 88% cotton and 12% nylon blend that was post-treated with a flame retardant. As the clock runs, here is what the garments look like just before the propane torches are activated to simulate a fire. If you look at about knee and hip level, just beyond the mannequin, you can see some of the lit pilot lights. The propane torches are activated and both garments are immediately engulfed in a fireball that will last 4 seconds. After 4 seconds, the propane torches will turn off completely. Here's the moment the burners have gone off. The garment on the left, made with Nomex, is no longer burning. The FR-treated cotton nylon coverall is still on fire, what is referred to as after flame. The images are blurry because there's smoke in the burn chamber, which is a closed environment. This shot is 2 seconds after the burners are off. The smoke around the Nomex garment is clearing. The FR-treated cotton nylon garment on the right still has residual flames. Two more seconds have passed. This is 4 seconds after the burners are off. The flames on the cotton nylon treated garment are gone. The smoke is almost clear for the mannequin on the left, and smoke still surrounds the mannequin on the right. Here's the last screenshot of the series, taken 11 seconds after the propane torches were turned off. Smoke has cleared from around both mannequins. The garment on the left, made of Nomex, results in a predicted body burn of 34.4%. The fire retardant treated cotton nylon garment on the right tested out at 69.7% predicted body burn. Putting data from the American Burn Association and the Thermo-Man laboratory test results together, the average victim wearing the garment made with Nomex is estimated to have an 83% chance of survival. The average person in the FR-treated cotton nylon garment is estimated to have a 53% chance of survival. This was a 4-second burn test. For a simulated fire event that lasts 3 seconds, there may be measurable differences in the performance that equates to a measurable difference in injury cost. This graph shows the predicted body burn of comparable FR garments made of different materials. Wearing a 7-ounce fabric made with Nomex MHP would give a predicted body burn of 7.1%. Instead of a 7-ounce FR-treated cotton nylon blend fabric with a predicted body burn of 12%. Those numbers seem very small in difference, but that reduction in body burn could possibly lead to a reduction of $80,000 in treatment cost. What is even more dramatic is the difference between wearing any of the FR garments on the left with an estimated 0 to 20% body burn for a 3-second exposure, compared with that tall orange column on the right. It represents a person with no FR protection. Thermo-Man testing of a worker wearing a standard cotton shirt and jeans subjected to a 3-second event is predicted to have an 86.9 TBSA with an average hospitalization cost of $1 million. What do cost and saving mean for a real-world PPE program? Let's create a test case. Assume you have a 100-person workforce that needs FR coveralls certified to standard NFPA 2112. Each employee gets 3 sets of coveralls washed after every other wear using a commercial laundry facility. If I could veer off topic here for just a minute, I want to be sure to stress the importance of keeping FR clothing clean. Nomex is a high-temperature material. It does not ignite, melt, or drip at high temperatures. This is what makes it a great material for FR clothing. But the protection of a garment made with Nomex or other FR materials could be compromised if the garments are not clean. Just like we talked about putting a flammable chemical suit over an FR garment could be a bad idea, if you have a spill or soiled FR clothing and that substance stuck on the fabric is flammable, the FR protection may not work the way it was designed to work. So whether you use home laundering or commercial laundering, it is extremely important to keep your FR garments clean. All right, let's go back to our test case. Consider the total risk aversion cost for the 7-ounce FR-treated cotton nylon product and the 6-ounce Nomex 3A, the same 2 products shown in the burn test on the previous slides. With either product, you could provide FR coveralls to a 100-person workforce with 3 duplicate sets for 5 years at equal to or less than the cost of 1 OSHA recordable burn. OSHA predicts that 1 recordable burn injury, either from fire, electrical, or chemical sources, would cost a company $88,000. 100 employees could be protected with FR coveralls for 5 years for $90,000 in flame retardant treated cotton nylon or $48,000 in a Nomex 3A product. Let's instead compare a multi-year PPE program with the average cost of a hospital-treated burn injury in the United States. You could provide FR coveralls to 100 workers, 3 duplicate sets, for 12 years and spend less than the medical cost of the average burn injury survivor or non-survivor treated in the United States in the last 10 years. Recall that the average medical cost for a burn survivor is $340,000. A non-survivor is $257,000. A 12-year total program cost for FR coveralls made of fire-retardant treated nylon cotton would be approximately $216,000, and FR coveralls made with Nomex 3A would be about $115,000. So here are the big takeaways from today's webinar. Burn injuries do not always show up on the radar as a major threat because they occur less often than other on-the-job injuries. This is absolutely true, but a burn injury is one of the most costly injuries that can occur. Medical costs are not the only issue. Manufacturing loss, legal costs, and fines will almost certainly follow. Be sure to consider burn threats in your hazard analysis. Be sure to consider multiple burn threat sources in your hazard analysis. And be sure all of the pieces and parts of your workforce PPE not only address the necessary threats, but they are also designed to work together. And lastly, dig deeper to understand the level of protection offered by competing products. Two products can both meet minimum standards, but may offer different levels of protection. A higher level of protection can significantly impact medical costs from a burn incident and should be calculated into the buying decision. My hope is that you found this information to be helpful and applicable to your work site. I encourage you to reach out with any questions either now or at a later time. My contact information is included in the bottom of this slide for any remaining questions. And now we turn the program back over to Jerry for questions.
Very good. Thank you so much, Caroline. This is a very eye-opening presentation for sure, and a lot of sobering information. So thank you for just doing a great job with it. And I do want to tell everybody we have a good amount of time left for the Q&A. If you have questions, there's still time to submit them, so please do so. But let's get to the first one anyway. We've got some good questions that have come in. Here's a good starter. You showed a chart that the costs of a PPE program with Nomex coveralls would be less than FR-treated cotton. How can that be if the cost to buy Nomex is more than cotton?
Well, initial garment price may not be the best indicator of the life cycle cost for a multi-year PPE program. Laundering studies have been done by commercial launderers and show that an average FR garment made of Nomex 3A 6-ounce fabric, that's the same one used in the last two test cases, can be washed and worn at least 125 times without compromising protection and appearance. A 7-ounce fire retardant treated cotton nylon blend garment in the same test can be washed and worn only up to about 40 times. This means a garment made of Nomex would last 2 to 3 times longer than a competitive product. So this means a garment made of Nomex will need to be replaced about 2 to 3 times less often than an FR cotton nylon blend. So over the life cycle of a multi-year PPE program, using FR garments made with Nomex may actually cost less.
That's a great answer. Thank you. You spent a fair amount of the presentation talking about the importance of doing a hazard assessment. So someone asked, where could I get information on how to do a hazard assessment such as you've described?
Well, my first recommendation would be the OSHA website. It's a great starting resource for companies that need to perform or update their risk assessment. OSHA standards require all employers to perform a job hazard analysis for each job task. The analysis looks for things like trip hazards, fall hazards, noise, and things that cause burns, flammable substances, electricity, chemicals. The employer has the responsibility to identify hazards in each job function and then select the proper PPE to protect against the threat. There are links off the OSHA website to connect users to toolkits, training, consultants that also can assist with hazard assessment. And once hazards are identified, a good source of information would be to look at the standards used for that type of threat. For fire and flame, the two main standards are NFPA 2112, that sets the minimum predicted body burn, and ASTM-F 1930, and that outlines the test protocol for a mannequin system like Thermo-Man. Arc hazards have their own set of standards. Chemical burns have their own set of standards as well.
Okay, perfect. Thank you. Here's a very good question I think probably a lot of us have. The questioner asks, if I am wearing a fire-resistant garment, can I still get burned?
Well, the short answer is yes. There are different levels of protection in different FR garments. So think about a firefighter's turnout gear. It offers a very high level of protection, but there's a trade-off there for comfort and mobility. It's designed for a different threat than, say, a manufacturing facility FR coverall or even a lab coat. Most industrial FR garments are designed to be worn all day and provide enough mobility and comfort that the job can be done effectively. In the event of an accident, the function of the FR garment is to minimize burn injury while giving the victim time to escape the event. So it's a very short period of time. And that's different from a firefighter who wears FR protection. They don it for a short period of time and use it in an ultra-high hazard environment. The bottom line would be to find the PPE protection level that best matches the potential hazard in the workplace. And also remember, PPE is best used as the last line of defense or protection.
Very good, thank you. I think this is a natural follow-up to what you just mentioned. You were talking about manufacturing. And the questioner says it's interesting that most burns occurring in workplaces are in manufacturing. Why is this?
I think it's just the nature of the industry. That is a large category that would represent lots of different industrial settings. And there are just a lot of hazards.
It's not so much that segment is failing to understand the hazards that they're facing, is it?
Well, there are particular hazards in particular industries, of course. It's interesting that food service shows up on that list. And then even in particular, fast food, you think about there are a lot of high temperature environments, work environments there. And pizzerias, same thing, where people are in and out of pizza ovens. So I think manufacturing just has a number of places where you are looking at electricity, obviously. You're looking at materials that can cause chemical burns. And then there are lots of high temperature applications as well where you have the potential for a thermal burn.
Good answer. Thank you. We've got a few more. Here's a good one. Why were some of the burn tests for 3 seconds and some were for 4 seconds?
Well, not every workplace is the same. Jobs are different. Every accident is different. And even no two people are exactly alike. So it's almost impossible for one single standard to create a laboratory testing protocol that would accurately simulate every possible accident. At DuPont, we use all the tools we have available to us to test our products and competitive products. We test things in multiple ways and under multiple conditions to gain as much information as we can. And then we use that information to advance technology so that we can make the best products to provide the best protection.
Very good. Thank you. We've got a couple more. Here's a good one that just came in. What are the specific recommended undergarment material types to maximize protection?
You would want to prefer cotton and avoid synthetics. The problem with synthetics is that they drip, and so the nature of the burn is much more severe because you've got that coating of a synthetic material on the layer of the skin. So it is recommended that undergarments should be cotton.
Very good. Thank you. We've got one more, and there is still time. If anybody has another question, please do submit it. But we have one more at this point anyway. And it's this. One of your examples of the costs of burn injuries seems especially important to me. A contractor was seriously burned, but the host employer was fined along with the contract company. Your thoughts?
Well, I think the resolution of that particular situation found fault with both companies. And so from a legal standpoint, both companies also shared the burden of the financial judgment to award money to the burn victim. And it is a complicated case. I think it's difficult to know exactly the details of what went wrong. But I believe there was miscommunication between the facility Qualcomm and the subcontractor that led to that arc flash incident.
Right, as you said, very important. Thank you. A couple more actually have come in, so let's do these. What's the difference between self-extinguishing and flame-resistant?
Well, there are different materials, and they act differently in the fire event. So Nomex does not actually burn. It doesn't drip. And so because it doesn't burn, you could look at it as self-extinguishing. A product like cotton, for example, does support burn, and it will continue to burn until that matter is not there or the oxygen is not there to support the flame.
All right, very good. Thank you. One more, and this is an interesting one. Is most flame-resistant clothing also anti-static material?
Well, anti-stat is an important property, and so what many companies do, including DuPont, is we incorporate anti-static materials in a blend that go into the fabric for an FR garment. So what we are trying to protect against is nuisance static for a person wearing a garment manufactured with Nomex. So we were talking about the different test methods, the different lengths of time, and so that's just another place where DuPont and other companies that participate in the PPE protective garment arena are always looking to optimize products. And so we may add other components to offer other features.
That's a great answer. Thank you so much. We have reached the top of the hour. I really want to thank our speaker, Caroline Holtzman, for her excellent presentation today. Really good job. And also our sponsor, DuPont Nomex. Remember, in the next day or two, we will be emailing you a link to an archived version of this webinar so you can review it or pass it along to your colleagues. Thank you very much for attending, and this concludes today's webinar.